Another derivative video here. We took a look at, in our first video, the power rule, then the product rule, then the chain rule. So now we obviously want to take a look at and learn a little bit about what happens when you have division, when you start with a function that has division in it. For example, if you have 2x to the fourth divided by x, well, let's keep it simple. If you have 2x to the fourth divided by 3x to the third minus 6x, or if that's your function, the quotient rule is kind of interesting, right? We're going to refer to this as, refer to the top section sort of informally as the high, right? This is the high, and we're going to refer to this bottom denominator as the low. Alright, so the quotient rule is kind of interesting. It's kind of an easy way to remember it. F prime of x using the quotient rule is going to be low times the derivative of high, we'll call that d high, minus high, and I'll move this over a little bit here. I'll move it down here actually. Minus high times, you probably guessed it, derivative of the low, all divided by the low squared. Alright, so it's kind of like a little mnemonic device, right? Low d high minus high d low over low squared. It's a really easy way to remember it. Low d high minus high d low over low squared. That's how I remembered it back in high school, and that's probably the best way to do it. Low d high minus high d low over low squared. So here we go. Let's actually use it. F prime of x is equal to the denominator, doesn't change, times the derivative of the high, which is power rule, 8x cubed, minus high, doesn't change, times d low, derivative of the low, is that, all divided by the low squared. Alright, simplify. So f prime of x is equal to, let's see here, we can take and do a ton of distributive property. Alright, we can distribute. Alright, let's do that. So we have 24x to the sixth minus 48x to the fourth. Oh, I forgot an 8, looks like. 48x to the fourth minus, and then we'll put like brackets, right? You should probably put brackets around this. Yeah, so we have, let's see, 2 times 9 is 18x to the sixth minus 12x to the fourth. Alright, I put brackets around it because this minus sign is pretty important, right? That's going to affect everything after it. And we divide that by low squared, which is basically just foiling, right? You're going to kind of like do a little distributive, binomial times binomial. So if you want to, you can kind of off to the side here see that it's a FOIL. First times first, outside, inside, last, right? So we have, let's see, 9x to the sixth minus 18x to the fourth minus 18x to the fourth plus 36x squared. Simplify a little bit more. F prime of x. Let's see, numerator is 24x to the sixth minus 48x to the fourth minus 18x to the sixth plus 12x to the fourth. We can simplify the denominator as well. We'll combine like terms. Let me separate these two. We'll combine like terms. In the bottom we have 9x to the sixth minus 36x to the fourth plus 36x squared. Simplify again. We have some common like terms in the numerator. So let's see, we have 24x to the sixth. Let's see, we have that guy right there and this guy right here. And then we'll combine as well. We'll do fourth terms as well. let's see the yellow terms. 24 minus 18. Looks like it's 6 x to the 6th minus 36 x to the 4th. And the bottom can't really change. All right, that's that's an okay answer. You can also take it a step further if you wanted to. You can take the numerator and kind of simplify it, and take the denominator and kind of simplify it. You can if you want, and I'll do that now. But depending on what your teacher wants you to do, this right here might be an okay answer. That is the derivative of what we started with. But I'll take it a step further and look at the numerator and kind of ask myself, what are the common factors, the common things inside? 6 and 36, oh geez, that's easy, that's 6, right? They both have 6's inside of them, right? So we have 6, and then they both have x's, and we always take the lowest of the two exponents. So the greatest common factor here in the numerator is 6x to the 4th. So when we divide that out, we get 1x to the 2nd power minus 6, and that's just let's see, minus 6. That's just x. I guess that's x to the 0 power. So let's just call it minus 6, right? And in the bottom, we can also take like terms out of here. 9x squared. Those are your common factors, right? And when you divide that, we get x to the 4th minus 4x squared plus 4. Yeah, that works. And let's see here. Is there anything else we can do? Yeah, absolutely. We can, and again, depending on what your teacher's looking for in terms of complexity, right? What I'm going to do is look at since I have terms on the outside here and here, I can simplify those. So the 6 and the 9, they simplify 2 and 3. So let's do that. So it's 2 and 3. The x to the 4th, the x to the 4th, and the x squared, they do the same, leaving you with just x to the 2nd in the top. And I'll rewrite the rest. And next you want to look at, to see if you can actually factor anything, if this thing is factorable or if this thing is factorable. And if they were, then you would go ahead and factor it out. I mean, the top doesn't really simplify too easily, so we'll just kind of leave that like that. The bottom you can actually factor out into two binomials, right? It's going to be x squared minus 2, x squared minus 2. And to check that, you would just FOIL it, right? So I think the simplest answer here would be to say, since there are two of these, they're exact copies of each other, x squared minus 2, x squared minus 2, I would probably just write that once and then raise it to the 2nd power. And I think that is the easiest, or the simplest rather, form. Alright, so there was a quotient rule for you. Again, this is something that you're going to want to memorize. This little jingle here, low d high minus high d low over low squared.